This is a brand new engine that GM condemned, and we're gonna figure out why it was.
While the automotive world was obsessing over electric vehicles and predicting the death of internal combustion engines, General Motors quietly made a move that sent shockwaves through Detroit.
General Motors, we believe in an all-electric future. We're working to a goal where we have zero crashes, zero emissions, and zero congestion.
They're betting nearly $1 billion on a brand new V8 engine, and the timing couldn't be more surprising.
We are here at the General Motors Tonawanda engine plant where they build their V6 and V8 engines and some four cylinders.
At a moment when everyone expected GM to double down on batteries and motors, they pivoted hard back to gasoline power. This isn't a small side project or a nostalgic farewell tour. This is a massive, strategic investment that signals something important about where the car industry is actually heading versus where we thought it was going. The $888 million bet nobody saw coming. In early announcements that caught most analysts off guard, General Motors revealed they're investing roughly $888 million into their Tonawanda engine plant near Buffalo, New York.
General Motors tells us this is the single largest investment. GM planning to invest $888 million into the Tonawanda propulsion plant.
That's not maintenance money or a modest upgrade. That's transformation-level investment to build an entirely new generation of V8 engines from the ground up. The plant, which has been cranking out engines for decades, is getting a complete overhaul to produce what GM calls their sixth-generation small-block V8 architecture. The shock factor here isn't just the dollar amount. It's what the money represents. For years, GM and other major automakers have been loudly proclaiming their commitment to an all-electric future. GM specifically set a goal to go completely electric by 2035, phasing out internal combustion engines entirely. So when news broke that they were pouring nearly $1 billion into new combustion technology, people started asking questions. What happened to the electric revolution? Why would you invest this heavily in something you plan to kill off in just over a decade? The timeline makes it even more interesting. Production of these new V8s is scheduled to begin in 2020, which means GM is planning to sell combustion-powered vehicles well into the 2030s and likely beyond. You don't make an $888 million bet on a technology you plan to abandon. The investment covers new tooling, manufacturing equipment, facility upgrades, and the engineering infrastructure needed to build engines that meet future emission standards while delivering the performance truck and SUV buyers expect. This isn't just keeping the lights on at an old factory. This is betting big that internal combustion still has a profitable future, at least for certain types of vehicles in certain markets. What makes this sixth-generation V8 different? GM isn't just building the same old engine with a fresh coat of paint. The sixth-generation small-block V8 represents a genuine technological leap forward in combustion engine design, even if that sounds contradictory in an age of electric motors. The new architecture will launch in two displacement options, roughly 5.7 liters and 6.6 liters, giving GM flexibility to match engine size to vehicle requirements. But displacement numbers only tell part of the story. The real advances come in how the engine burns fuel and manages the thermal energy that process creates. GM claims the new V8 features what they call new combustion and thermal management innovations designed to extract more useful work from every drop of gasoline while minimizing wasted heat and harmful emissions. Combustion chamber design has been refined to promote more complete fuel burning, reducing unburned hydrocarbons and improving efficiency. The thermal management systems represent a significant evolution from previous generations. Modern engines generate enormous amounts of heat, and managing that heat efficiently affects everything from performance to emissions to longevity. The new V8 incorporates advanced cooling passages, likely with more precise control over coolant flow to different parts of the engine depending on operating conditions. This allows the engine to reach optimal operating temperature faster when cold, which reduces emissions during warm-up, and maintain precise temperature control under heavy loads, which protects components and maintains performance. The efficiency improvements matter for more than just fuel economy, though GM obviously wants to reduce consumption where possible. Better efficiency means less heat rejection, which means more energy going into moving the vehicle rather than heating up the atmosphere around the engine bay. It also means the engine can meet increasingly strict emissions regulations without sacrificing the power and torque that truck buyers demand. Performance claims suggest these engines will deliver more horsepower and torque than the current generation while using less fuel and producing fewer emissions. That's the holy grail of engine development, and it's extremely difficult to achieve. The fact that GM believes they can pull it off speaks to how much engineering effort has gone into this new architecture. We're talking about advances in materials, combustion modeling, computer control systems, and manufacturing precision that simply weren't possible or economically viable in previous generations. Why GM is reversing course on its EV promise. The shift back toward combustion investment looks like a reversal, and in some ways, it is. GM spent years building up its electric vehicle credentials, announcing the Ultium battery platform, committing to an all-electric future by 2035, and positioning itself as a leader in the transition away from fossil fuels. So what changed? Market reality, for one thing. While EV sales are growing, they're not growing as fast as the most optimistic projections suggested they would. Consumer adoption has been slower than expected, particularly in certain vehicle segments and regions. Meanwhile, demand for traditional trucks and SUVs, especially large ones with significant towing capacity, remains incredibly strong. And here's the uncomfortable truth for automakers: they make substantially more profit on internal combustion trucks and SUVs than they currently make on electric vehicles. Battery costs, despite falling over time, still represent a huge portion of an EV's price. The supply chain for EV components remains challenging, with bottlenecks in battery production and raw material sourcing. By contrast, GM knows how to build combustion engines profitably. They have decades of experience, established supply chains, and production processes refined to extract maximum margin. Walking away from that profit stream before electric vehicles can replace it financially, not just symbolically, started to look like poor business strategy. There's also the infrastructure question. The charging network build-out in the United States and globally is proceeding, but not at the pace needed to support mass EV adoption in the near term. Range anxiety remains real for many consumers, especially those who use trucks for work or recreation in areas far from charging stations. GM's strategic pivot isn't really about abandoning electrification. It's about acknowledging that the transition will take longer than initially predicted, and that internal combustion engines, especially advanced, efficient ones, will remain part of the product portfolio for longer than the 2035 target suggested. You could call it a more realistic timeline, or you could call it backpedaling. Either way, it reflects the actual market GM sees, rather than the idealized market they hoped for. The truck and SUV factor. If you're wondering where these new V8 engines will actually end up, look at GM's truck and SUV lineup. That's the natural home for this technology, and it's where the business case makes the most sense. Full-size pickup trucks like the Silverado and Sierra, large SUVs like the Tahoe, Suburban, Yukon, and Escalade, these vehicles represent some of GM's most profitable products. They're also the vehicles where electric powertrains face the biggest challenges. Towing capacity is a major consideration. When you load a trailer behind an electric truck, range drops dramatically. Physics doesn't care about your environmental commitments. The energy required to move a heavy load up a mountain pass is the energy required, and batteries currently can't match the energy density of gasoline for these demanding applications. The typical truck buyer who tows a boat or camper regularly isn't ready to plan routes around charging stations or accept a 50% range reduction when loaded. They want to fill up in 5 minutes and keep moving. Consumer demand in this segment remains strongly tilted toward traditional powertrains, especially among buyers who use trucks for actual truck things rather than just commuting. These customers value proven technology, long range, quick refueling, and the confidence that they can handle any task without worrying about battery percentage. The business case for GM is clear. Keep these high-margin customers happy with increasingly efficient combustion engines while electric technology matures. This also gives the charging infrastructure more time to expand and battery technology more time to improve energy density and reduce costs. Meanwhile, GM protects its profit margins and market position in segments where it's traditionally been strong. The reality is that electric trucks and SUVs exist now, including GM's own Hummer EV and upcoming electric Silverado, but they're serving a different part of the market. The new V8 investment suggests GM believes there's room for both, and that the combustion segment will remain commercially viable for years to come. What this means for the competition. GM's decision to invest heavily in new combustion technology doesn't exist in a vacuum. Every other major automaker is watching and recalculating their own strategies. Ford has been aggressive with electric vehicles, launching the F-150 Lightning and Mustang Mach-E while investing billions in battery production. But Ford has also continued developing its combustion engines and has made no indication it plans to abandon them anytime soon. The competition between Ford and GM in the truck market is intense, and if GM shows up in 2027 with a significantly more efficient and powerful V8, Ford will need an answer. Stellantis, the corporate parent of Ram, Jeep, and Dodge, has similarly committed to electrification while continuing to develop high-performance combustion engines. The fact that GM is putting this much money into V8 development might embolden Stellantis to extend its own combustion investments rather than rushing toward an all-electric lineup. Toyota has been perhaps the most cautious of major automakers regarding full electrification, continuing to invest in hybrid technology and even hydrogen fuel cells while developing battery electric vehicles more slowly. GM's move might vindicate Toyota's more gradual approach and encourage other manufacturers to hedge their bets rather than going all in on electric. The potential domino effect is real. If one major automaker demonstrates that there's still strong demand and healthy profits in advanced combustion engines, especially for trucks and SUVs, others will follow. Nobody wants to be left without a competitive product in a segment that continues to generate revenue while their electric investments take longer to pay off than expected. There's also a competitive technology angle. If GM's new V8 delivers genuinely impressive efficiency and emissions improvements, it raises the bar for everyone else. Other manufacturers will need to respond with their own advanced combustion technology or risk losing ground in comparisons and reviews. The result could be a new round of combustion engine innovation, something many observers thought was basically finished as the industry pivoted to electric. That said, this doesn't mean the electric transition is canceled. It means the transition is becoming more complex and extended than the simple narrative suggested. Different regions, different vehicle segments, and different customer bases will transition at different rates. GM's investment acknowledges that reality rather than pretending there's a single linear path forward. The reality check on electric transition. The gap between electric vehicle enthusiasm and actual consumer adoption has been one of the biggest stories in the automotive industry over the past few years. Early predictions suggested we'd see rapid, near-total conversion to electric powertrains by now, but reality has been considerably messier. Infrastructure remains a huge challenge. Yes, charging networks are expanding, but they're not expanding fast enough or in the right places to serve mass adoption. Rural areas remain underserved. Many apartment dwellers and city residents don't have reliable access to charging. Fast charging stations still can't match the speed and convenience of a gas station, especially when they're occupied or malfunctioning. Consumer hesitation is broader than just charging anxiety, though that's certainly part of it. Purchase price remains a barrier despite incentives. Many consumers are waiting for prices to drop further before considering an EV. There's also uncertainty about battery longevity, replacement costs, and resale value. First-generation technology often has bugs and limitations, and many consumers would rather wait for more mature products. The charging network limitations extend beyond just quantity to reliability and payment systems. Stories of broken chargers, incompatible payment systems, and long waits during peak travel times create negative perceptions that spread through consumer networks. Until charging becomes as reliable and convenient as refueling, adoption will face headwinds. Cost barriers persist despite falling battery prices. Electric vehicles still generally cost more than comparable combustion vehicles, and while operating costs are lower, the upfront premium discourages many buyers, especially those who keep vehicles for shorter periods where fuel savings don't offset the initial cost difference. The all-electric now timeline was always optimistic, driven more by aspirational thinking and policy goals than by realistic assessment of technological, infrastructure, and consumer readiness. The automotive industry is enormous, with complex global supply chains and hundreds of millions of existing vehicles. Transforming that system fundamentally takes time, more time than enthusiastic projections acknowledged. GM's investment in combustion technology doesn't mean electric vehicles have failed. It means the transition will be longer and more gradual than initially predicted, with combustion, hybrid, and electric powertrains coexisting for longer than the simple narrative suggested. Environmental and regulatory tightrope. Investing in new combustion engines in 2024 means navigating an increasingly complex regulatory landscape. Emission standards continue to tighten globally, and GM has to ensure their new V8 can meet not just today's requirements, but standards that will be in effect throughout the engine's production life, potentially into the 2030s. The engineering challenge is significant. You need to reduce carbon dioxide emissions, which basically means burning less fuel. You need to reduce nitrogen oxides, which requires careful control of combustion temperatures and advanced exhaust treatment. You need to minimize particulate emissions and unburned hydrocarbons. And you need to do all this while maintaining the performance and reliability customers expect. GM's combustion and thermal management innovations are aimed squarely at this challenge. More complete combustion means less wasted fuel and fewer harmful byproducts. Better thermal management allows more precise control of combustion processes, which directly affects emissions. Advanced exhaust treatment systems, likely including improved catalytic converters and possibly particulate filters, will clean up what does come out of the combustion chamber. The regulatory landscape they're navigating includes not just federal standards, but state-level requirements, particularly California's strict emissions rules that often influence standards nationwide. It also includes international markets with their own requirements. An engine platform destined for global sale needs to meet the most stringent standards it will face anywhere. Balancing performance and environmental responsibility isn't just a technical challenge, it's a marketing one. GM needs to convince environmentally conscious consumers that a gasoline engine can be responsible, while also convincing performance enthusiasts that emissions equipment won't strangle the engine's power. That's a narrow path to walk, but modern engine technology has become remarkably sophisticated at managing these competing demands. The reality is that a 2027 V8 engine will be vastly cleaner than engines from even a decade ago, let alone older generations. If GM can demonstrate genuinely impressive efficiency and emissions improvements while maintaining performance, they might find broader acceptance than expected, even among consumers generally favorable toward electrification. The hybrid future nobody's talking about. Here's what GM's investment actually signals when you step back from the electric versus combustion framing. We're entering an extended period of powertrain diversity where hybrid technology plays a much larger role than current discussions acknowledge. Pure internal combustion and pure battery electric represent two ends of a spectrum, but most consumers and use cases probably sit somewhere in the middle. Hybrid powertrains, whether traditional parallel hybrids, plug-in hybrids, or more advanced systems, offer immediate benefits without requiring complete infrastructure transformation. They reduce fuel consumption and emissions compared to pure combustion while eliminating range anxiety and charging infrastructure dependence compared to pure electric. The practical middle ground they represent makes sense for a broader range of consumers than either extreme. GM's new V8 could easily become the foundation for hybrid powertrains, particularly in trucks and SUVs where electrification of accessories and limited electric-only driving could deliver meaningful efficiency gains without the complications of full electrification. Pair a highly efficient combustion engine with modest battery capacity, say, and an electric motor, and you get the best of both worlds for many applications. Gradual electrification looks less like a switch being flipped and more like a dial being turned. Increasing battery capacity, increasing electric motor capability, and decreasing reliance on combustion engines can happen incrementally over years or decades. This allows infrastructure to catch up, technology to mature, and consumers to adapt at a pace that feels manageable rather than forced. The extended hybrid transition period this investment implies. Doesn't make for exciting headlines or bold policy statements, but it probably represents what will actually happen across much of the market. You'll see pure electric vehicles succeed in certain segments, particularly smaller vehicles in urban areas with good charging infrastructure. You'll see pure combustion vehicles persist in applications where electrification remains challenging. And you'll see a huge middle ground of hybrid vehicles in various configurations, serving the needs of consumers who want some benefits of electrification without fully committing to it. GM's $888 million bet on V8 engines makes perfect sense in this context. Those engines can serve pure combustion vehicles for customers who want them, while also serving as the foundation for sophisticated hybrid systems that will probably represent the volume sweet spot for years to come. General Motors' decision to invest nearly $1 billion in a brand new generation of V8 engines tells us something important about the automotive future we're actually getting rather than the one we imagined. The transition away from combustion will happen, but it's going to be longer, messier, and more complicated than the clean narratives suggested. Different technologies will coexist, serving different needs for different customers in different places, and in that complex, uncertain landscape, a really good gasoline engine still has tremendous value. Whether this move looks brilliant or short-sighted will depend on how the next decade unfolds. But one thing is certain: the internal combustion engine isn't dead yet, and it's about to get a very expensive, very sophisticated second wind.